CPU. The central processing unit is often called the brain of the computer because it carries out the instructions that make every program function, from simple calculations to complex system tasks. It comes from decades of shrinking technology, where early computers filled entire rooms and modern chips now fit inside a fingernail-sized package. Inside the CPU are billions of tiny transistors that switch on and off to represent and process data in binary form. These switches work in precise timing cycles, allowing the processor to complete billions of operations per second. Modern CPUs also include multiple cores, which means they can handle several streams of work at the same time instead of processing everything one by one. This is why multitasking, like running a browser, music, and software together, feels smooth on modern systems. The performance of a CPU influences almost everything a computer does, from loading applications to how quickly files are processed. GPU. The graphics processing unit is built to handle visual and mathematical workloads that involve large amounts of repeated calculations. It became especially important as computers moved into advanced gaming, digital animation, and high-resolution video processing. Unlike a CPU, which focuses on a few tasks at high speed, a GPU is designed with thousands of smaller cores that work together at the same time. This structure allows it to process images, lighting, shadows, and textures efficiently. Over time, GPUs also found use outside of graphics, especially in artificial intelligence, where large datasets need to be processed quickly in parallel. In modern computers, the GPU can be a separate dedicated card or built directly into the processor. Its power often determines how realistic visuals appear in games and how smoothly complex visual tasks run. RAM. Random access memory is the computer's short-term workspace where data is temporarily stored while it is actively being used. It developed as a solution to the slow speed of long-term storage, giving the processor quick access to the information it needs in real time. When you open a program, its data is loaded into RAM so the CPU can reach it instantly without waiting for a drive to respond. RAM is extremely fast compared to storage, but it only holds information while the computer is powered on. Once the system shuts down, everything stored in RAM is erased completely. The amount of RAM in a system affects how many applications can run at once without slowing down. More RAM allows smoother multitasking and better performance in memory-heavy tasks like video editing or large simulations. Motherboard. The motherboard is the main circuit board that connects and allows communication between every part of the computer. It evolved from early simple boards into highly complex layered designs with thousands of pathways that carry both data and power. The CPU, RAM, storage devices, and expansion cards all plug directly into it through specific slots and connectors. It also contains important supporting chips that manage things like audio, networking, and power distribution. Every signal traveling between components passes through the motherboard, making it the central hub of the entire system. Its layout and quality can affect how upgradable and stable a computer is over time. Without it, individual components would have no way to work together as a unified machine. Storage drives. Storage drives are responsible for holding all long-term data on a computer, including the operating system, applications, and personal files. They originated with hard disk drives that store information on spinning magnetic platters read by moving mechanical arms. While effective, those older drives were limited by physical movement, which made them slower and more fragile. Solid-state drives replaced many of these limitations by using flash memory with no moving parts. This allows data to be accessed almost instantly, greatly improving boot times and file loading speeds. Storage drives retain information even when the computer is powered off, making them essential for permanent data storage. Over time, they've become faster, smaller, and more reliable as technology has advanced. Power supply unit. The power supply unit is responsible for converting electricity from a wall outlet into usable power for all computer components. It takes high-voltage alternating current and transforms it into lower-voltage direct current that hardware can safely use. This process involves careful regulation to ensure stable and consistent energy flow. Without this regulation, sudden changes in power could damage sensitive components like the CPU or motherboard. As computers became more powerful, power supplies also evolved to deliver higher wattage and greater efficiency. They include safety protections that shut the system down if electrical issues are detected. In many ways, the power supply acts as the foundation that keeps the entire system running reliably. Cooling system. The cooling system is designed to manage the heat produced by computer components during operation. As processors and graphics units became faster, they naturally began generating more heat, which needed to be controlled to avoid damage. Cooling systems use fans to move air through the case and across heat-generating parts. Heat sinks are attached to components like the CPU to draw heat away and spread it out more effectively. In higher performance systems, liquid cooling is sometimes used, where fluid carries heat away to a radiator for dissipation. Proper cooling is important not only for safety but also for maintaining consistent performance, since overheating can cause parts to slow down automatically. A well-designed cooling system helps extend the lifespan of the entire computer. Computer case. The computer case is the protective structure that houses all internal components and keeps them physically organized. It evolved from basic metal enclosures into carefully designed frames that prioritize airflow, accessibility, and extendability. Inside the case, every major component is mounted in a specific position to allow proper connections and cooling. Cable routing systems help keep wires organized so that airflow is not blocked. While the case doesn't directly affect processing power, it plays an important role in system stability and maintenance. Good case design can significantly reduce heat buildup and make upgrades easier. It also protects sensitive hardware from dust, impact, and environmental exposure. Network interface card. The network interface card is the component that allows a computer to connect to other devices and access networks such as the internet. It developed alongside the growth of computer networking when machines needed a reliable way to communicate with each other over distances. A network card can be built into the motherboard or added separately as an expansion card. It works by converting digital data from the computer into signals that can travel through cables or wireless transmissions. On the receiving end, it converts those signals back into usable data. Speed and reliability of the network interface affect how quickly data can be sent and received. It's essential for everything from browsing websites to online gaming and file sharing. BIOS and UEFI. The BIOS and UEFI systems are firmware systems that initialize the computer and prepare hardware before the operating system starts. They originated as basic software stored on a chip that would perform simple checks and startup routines when a computer was powered on. Over time, BIOS was replaced in most modern systems by UEFI, which offers faster boot times and more advanced features. These systems detect hardware like storage drives, memory, and processors, making sure everything is functioning correctly before loading the operating system. They also allow users to adjust low-level settings that affect how the computer runs. Even though they operate quietly in the background, they're the first step in every computer startup sequence.